In this video, we're looking at a couple problems that have to do with volume and surface area of a sphere. In this problem, it says the base radius of a cylinder and the radius of a sphere are equal. And so we can call both of them R. The volume of the cylinder, so if you've got volume cylinder, is 3 times the volume of the sphere. So you can write this equation. Volume of cylinder equals 3 times the volume of sphere. What is the ratio of the height of the cylinder to the radius of the cylinder? Well, the volume of a cylinder is just going to be pi r squared h. And then the volume of the sphere, well, the r's are the same because it says the radius of the sphere and the radius of the cylinder are equal. And the volume of a sphere is simply 4/3 pi radius cubed. Well, what ends up happening is each of these have a pi. You can divide both sides by r squared as well. You're allowed to divide by the variable because r is always positive. It's not 0. So this r cubed becomes just r. And then 3 times 3 equals 4. And so you end up with h equals 4r. And you want to know what is the ratio of the height of the cylinder to the radius of the cylinder. Well, just divide both sides by r, and you get exactly what you want, h over r. Ratio of the height to the ratio of this radius, and that equals 4. So the correct answer is the height is 4 times the radius in this given scenario. In the next problem, we're asked to look at the volume of a sphere inscribed in a cube of side length 12. And so this cube has got side length 12, and you have this sphere inside of it. Well, this problem is actually very simple because if you think about the point at the top and the point at the bottom where the sphere hits the cube, that just represents a diameter, and it's equal to 12. And so the diameter of this guy is just 12, which means its radius is 6, and so the volume is simply 4/3 pi, and then the radius is 6, so radius cubed. And when you multiply this all out, it ends up being 288 pi, right? You end up with 4/3 of 216. 4/3 times 216 is 288, and then times pi. So the answer is 288 pi. So a sphere inside a cube is very easy. The radius is just half the side length of the cube. Now, the other possibility is the cube inside the sphere, as this picture shows. And this is a little bit more complicated. It says, find the surface area of a sphere that is a cube with surface area of 384 inscribed in it. Well, first off, we got to think about what this means. A cube with a surface area of 384. Remember, a cube is just 6 squares on the outside, so we can say that the surface area of a cube is just 6s squared. So we set that equal to 384. When we divide both sides by 6, we get s squared equals 64. So that tells us s equals 8, because the square root of 64 is simply 8. So now we know that the side length is 8. But that doesn't tell us anything right away about the radius or diameter of this sphere. And it turns out that the radius or the diameter of the sphere is also what we refer to as a space diagonal of the cube. Going from one vertice to the exact opposite, both of those points are actually on the sphere, and they go through the center, and so the space diagonal is a diagonal. It's the diameter of the sphere. And it turns out that in a cube, the space diagonal can be found by this. Side times root 3. You can calculate it by putting in this right here as side root 2, and this is side, and using the Pythagorean theorem. But the space diagonal is side root 3, so our diameter of our sphere is 8 root 3, so our radius is half that, which is 4 root 3. And you want to find the surface area of a sphere, so 4 pi times 4 root 3 squared, 4 pi r squared. Well, 4 root 3 squared just turns out to be 48, so the answer is 192 pi. So 192 pi. Remember, the So the diameter of a sphere that has a cube inscribed in it is equal to the space diagonal of the cube, and the space diagonal of the cube is always just going to be psi times root 3.